important, right? Day one is really important in math because if you get day one, it helps, right? Doesn't it? So our objective today, 328, thanks Peyton for the pen, I'll give it back, is really simplifying roots. So let's list the first perfect squares. And I'm going to start, I'm going to start with square root of 4, square root of 9, square root of 16. Thanks, Dylan. Let me get you the notes. Square root of 16. Square root of 25, right? These are the perfect ones. These are the ones we just put in our notes. Square root of 36. Square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, and then square root of 144. Let's at least write those down, okay? Those would be my first 12 perfect squares. I left out 1 and 0 because those are pretty obvious. You'll never see the square root of 0 anyway. So, all right, write those down so I have them handy. All right. Now watch. Just watch. Just watch. Example 1, square root of 20. That is an irrational number. It's not a good number. It's what I like to call an ugly number. But let's call it what it really is. This is an irrational number. It's not a very good-looking number at all, is it, right? So the square root of 20 is irrational. But what we want to do is make it better. We can't get it from being irrational, but let's make it look better. How do we make it look better? Okay? Here's how it works. Everybody listening? Everybody listen. What times what makes 20? But we have to use one of these numbers. What times what makes 20? But we have to use one of these numbers.
4 times 5.
Perfect. Everybody agree? Yep. Square root of 4, square root of 5. I would not use 2 and 10 because 2 is not a perfect square, and 10 is not. I have to use one of these numbers. The reason I do that is the square root of 4 is what? What's the square root of 4? 2. So what I've done is I've reduced it. Now, square root of 5 is still an irrational number, but I was able to make it better. See how I made it better? I was able to get a perfect square out of it. So our goal is to find multiples of our square root where one of them is a perfect square. Our goal is to find the multiples, what times what makes this number, where one of them happens to be a perfect square, because then we can take the square root of that perfect square and take a number out. Okay, let's look at example 2. So example 2, the 3 is already out, so I'm just going to write the 3 down. 3 is already out, okay? Now, inside the square root, what times what makes 18? But you have to use one of these numbers.
9 times 2.
9 times 2. I wouldn't want to use 6 or 3. 6 times 3 is 18, but 6 and 3 are not one of these perfect squares. The key is to find a perfect square, okay? So I know what the square root of 9 is. Square root of 9 is 3, right? So I'm going to bring this 3 down that I had originally, times that 3 times the square root of 2. Now, square root of 2 is an irrational number. Okay, my goal was to find a perfect square and bring it out. My goal was to find a perfect square and take it out. And then once I take it out, 3 times 3 is 9. Square root of 2. What do you think? Not bad?
Pretty good.
Has to be one of these numbers. That's the key. Okay, number 3. Now, number 3, they are both perfect squares, aren't they? So what I'm going to do is not make it hard. I'm just going to think it as 2 different problems. The square root of 9 over the square root of 16, which is kind of sweet because I know what the square root of 9 is. It's just 3. And I know what the square root of 16 is. Just 4. How's that?
Pretty good.
Now, let's do the same thing on example 4. I'm going to go square root of 32 over square root of 25. Okay, and I see something. I hope you see something as well. Do you see something easy? The 25, right? Because the square root of 25 is 5, right? We could have written these down, I guess, if you don't know what the square roots are. So the square root of 25 is 5. but there is no square root of 32. So what I want to do is make the square root of 32 one of these numbers. One of these numbers. Something times something makes 32. What times what makes 32? Okay, 4 and 8 is great, but I'm going to use, okay, so I want you to watch 4 and 8. I'm going to use 16 and 2, and I'll show you why, okay? Watch 4 and 8. Glad you said that, thank you. Square root of 32. Watch. Square root of 4, square root of 8 is awesome. 2 square root of 8, great. Oh, we can do 8. Again, can't we do 8? So we go square root of 4, square root of 2 makes my 8, which makes another 2. And that's completely right. However, is there a faster way to get there? Can we do it faster? How about 16? How about 16 times 2? We go faster. This is totally correct, 4 and 8. But then you got to break down the 8. So you got to break it down. So if we could get the bigger number first, it shortcuts. Okay, I don't know, hopefully that made some sense. The bigger the number, the better, because then you can get it reduced more quickly. Okay, so, all right. I'm going to write this as the square root of 16 times the square root of 2. I know what the square root of 16 is. That's just 4, right? So I'm going to write 4 times the square root of 2 over 5. I cannot do the 2. Square root of 2, I am stuck with. Square root of 2 is an ugly number. Square root of 2 is, boom, it's just 1.41. Cannot break it down, so it becomes part of the question. But I like this. Look at this. I like this number better than this. Did you get? I mean, hopefully you agree. Square root of 2 is better than writing that number. In fact, the amazing part about this number is it never ends. It's like pi. It's like pi. It goes on forever. Let's write square root of 2. Not this 1.4142135562, blah, 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 right? All right. How about example 6? Well, before we do example 6, I know x to the 4th times x to the 4th is, x to the 4th times x to the 4th is, what's x to the 4th times x to the 4th? X to the 4th times x to the 4th is actually x to the 8th, because we add exponents. Now, if I took the square root of x to the 8th, I'm going to get x to the 4th. So really what I'm doing is taking half my exponent. So I'm going to take half my exponent. Always remember that, half the exponent. So I'm going to get, well, I know what the square root of 81 is. Square root of 81 is 9. And if I take half of my exponent, I get x to the 4th. Because x to the 4th times x to the 4th makes x to the 8th. So I took half, okay? Now example 3, we're going to do it. Example 3 is a little bit harder, but we'll go through it slowly, okay?
You mean example 7?
Yes, thank you. Yeah, it's Monday, huh? Thanks, Scott. So the 3 is done. The 3 is out. Leave the 3 alone. Just pull it out. 3 is a whole number. 27. Well, what times what makes 27 up here? What numbers would you use? What times what makes 27?
9 times 3.
Yeah, so I'm going to rewrite square root of 27 is the square root of 9 times the square root of 3. I need half the exponent, and since it's odd, I'm going to take 1 away to make it even. Now watch me do this trick. I'm going to make it x to the 6th and x to the 1. If it's an odd exponent, I need to make it even. If it's odd, I need to make it even because I take half of it. So by taking 1 away, x6, x1, I can take half of this one. All right, let's see what we have. The 3, this 3 is still there, but the square root of 9 is 3. This square root of 3, I have to leave this square root of 3. I have to. It's just, it's either this number or this number. And I don't want to write that 1.732050808 blah 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 blah. So I'm just going to leave it as square root of 3. Better answer. Now I'm going to take half of that, okay? So if I take half of x to the 6th, I get x to the 3rd. And then this square root of x, I can't take half of it, so I just leave it as the square root of x. So our goal is to take everything out we can. We take out perfect squares. We take out half exponents. We take half our exponents. What's left inside we can't take. We cannot take the square root of what's left inside. So let's tidy it up. So I'm going to go 9 x cubed square root of a 3x. And that's all I can do.
Oh, you can put the 3 next.
Right, we may as well, Scott, because they're both square roots, right? Okay, may as well put them together. And that's it. So our goal is to take out everything we can. And later on we'll do something with this, but not yet. Our goal is to just simplify them, okay? Okay, can I turn the page? All right, cube roots. Well, we can do cube roots. Let's list the first perfect cube roots. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. Cube root of 125 is 5. And I'm just going to probably go to the next one. Cube root of 216 is 6. I guess I can go one more. I got room. Cube root of 343, I think it is. 43 is 7. I'll double check that one. I'm pretty sure that's right. What is 7 cubed? 7 cubed. Yep, 343. Okay. All right, now we're going to do the same thing with cube roots, okay? So if we look at 24, and we're going to say what times what makes 24? 6 and 4, no. 6 times 4, no. We want one of those numbers. 2 times 12, no. I want one of those numbers, right? So how about 8-3, right? 8-3, everybody agree? Okay, so I'm going to rewrite this as the cube root of 8 times the cube root of 3, because 8, we needed one of these numbers, okay? The cube root of 8 is 2, right? There is no cube root of 3. It's just really an ugly number. I'll show you cube root clear. Cube root of 3. Yeah. How about cube root of 3 instead of this ugly decimal, right? This is an ugly decimal. I'd much rather write that in its place. So 2 times the cube root of 3. So what did I do? I found a number that I could cube root. I just need to find a number I could cube root. It has to be one of these. If I find a number that can cube root, I cube root it and bring it out, okay? All right, example 9. Well, I need to take not half of the exponent, but a third. 1/3 of this exponent. Take 1/3 of this exponent, which I can do that. But before I do that, I will. Before I do that, I'm going to do that. What about this 250? There you go, 125 times 2. So 125 times 2, perfect. So I'm going to go cube root of 125, cube root of 2, and then I'm going to take a third of this and have an x to the second power, okay? Scott?
So, in the other ones, we had to make the x positive.
Yes.
If for this, if it's like 9 or something, you don't need to make it positive. I mean, not positive, even.
Right. It's as easy as this. You just want to make it a multiple of 3. Because you're going to divide by
Yeah,
it.
that makes sense.
And square root's got a little invisible 2 in there, which we never write for a square root,
Yeah,
right?
yeah.
Right, if we ever did like there's an invisible 2 right there. Yeah. Okay. Yeah. Okay, so whatever the root is, you're going to divide by that number, okay, for the exponent. Whatever the root is, you'll divide by that number for the exponents, okay? So let's finish this up. Avis said 125, I agree, so the cube root of 125 is 5. I have this x squared, and I'm left with the cube root of 2, which I'm going to leave as a cube root of 2 because I'd rather have the cube root of 2, cube root of 2. I'd rather have that. I'd rather have this than that ugly decimal. Does that make sense? Much rather write this. Not only that, this is exact and this is not exact. Okay. All right, now example 10 looks ugly, but maybe we can do some things with it. Okay, 60, 60. Well, I don't know if 60 can be reduced at all, right? 60, I don't think we can do anything with the 60. So I'm just going to go ahead and say, okay, negative cube root of 60x squared. Sometimes you can't do anything with it. But on the bottom, cube root of 729, cube root of 729. I think that is a perfect cube root. Maybe.
Oh wait, we did go. It's
It's 9. I think it's in our notes, right? I think it's 9. I think the cube root of 729 is 9. It's in our notes. So we're going to have a 9. And then we're going to take a third of that. 1/3 of exponent. And we get a x to the 4th. So we take a third of x, y. There we go. Thank you. And that's it. That's all we can do. I like to do more, but 60 cannot be broken up into any of these numbers at all. And x squared is too small to take a third of it. Okay, so what I have, and we can do a real quick brain break, and then I've got an assignment for us, okay?